In this video, we'll be looking at how to find the area of a triangle using the formula a half base times height. Now I'm telling you the formula that we'll be using because in the future you may be interested in using the formula half AB sine C, and that is not what we are doing in this video, so I want to make that clear before you begin. Okay, so first of all, how did this formula come about? So in order to explain how the formula half base times height came about, I would need to show you a parallelogram. So our parallelogram can be a parallelogram that looks like this, or it could be a rectangle, but as long as you recognize that the area of a parallelogram, I'll say para for short, is equal to base times height, then you're partway there. If we take our parallelogram and we cut it in half at the diagonal, then we've actually created two triangles. Or triangles are congruent to each other. They're the same size, that red triangle right there and the blue one that I'm about to draw are congruent triangles, which means that the area of one of those triangles is half of the area of the whole parallelogram, which then follows that the area of a triangle, I'll call it tria for short, is a half of the area of the parallelogram, so a half base times height. So that's how we get the formula for the area of a triangle. So let's actually look at how we should be using that area formula. Okay, so the most important part to note when finding the area of a triangle is that the base and the height have to be perpendicular to each other. The base and the height, I repeat, must be perpendicular to each other, which means that in this particular case, we conveniently have our base and our height already there for us. So the area of a triangle, I'll just say triangle for short, half base times height. Our base here is 20. The height is perpendicular to the base, it's 8. And so the area of our triangle is a half times 20 times 8, and that will give us 80 meters squared in this example. All right, let's look at a slightly harder one. All right, so in this example, it's a lot harder because we're not explicitly given a base and a height. We do know, however, that this side is 19 and this side is 54.918. We also know that there's an arbitrary length out here that is 46, but how does that help us? So it's important to remember that the base and the height have to be perpendicular to each other. So now that we remember the base and the height have to be perpendicular to each other, again, checking this and this, they are not perpendicular. Okay, so what then? Well, first of all, ask yourself the question, which side is the base? It could actually be any side. It could be this side, or this side. However, it's probably not wise to make the base the unknown side. So either this side or this side would be the base. Now, if this side were determined as our base, then our height would be, I'll draw that in a very light lilac here. So if this side is our base, our height would have to be perpendicular to that. And so coming from the vertex of the other side, it would be that. So if our base is 54.918, that's our height. But that little lilac line would be extremely difficult to find because we don't have anything around it. Our other option is to make, and I'll make this green. All right, so from the other vertex, we can drop a height, and it is totally okay that this height is outside the triangle. So we're completing a right triangle, and this line here is our height, if that 19 is our base. All right, so what I've just done, I'll repeat. I completed the triangle so we could see what the height is in comparison to the base. All right, so now we have a base and we have a height that's perpendicular to it, even though it's on an extended line. All right, but Again, we don't have the measurement of the height. We do, however, have this random 46 inches right here. How does that help us? Well, you may notice that I am about to trace a right triangle, and in that right triangle I actually have all three sides. I have two sides, and I can find the third side. So in my right triangle, we have one side is 46. I will label it in black here. There we go. One side is 46. The hypotenuse is 54.918, and the height is what we're looking for. So since it's a right triangle, we can go ahead and set up the Pythagorean theorem. In the Pythagorean theorem, we know that a squared, I'll write that down, a squared plus b squared is equal to c squared. So a is our height, so height squared that we're looking for, plus 46 squared is equal to 54.918 squared. Let's get that to fit. That's a squared. Okay. So we can complete our Pythagorean theorem. Height squared is equal to 900 if you calculate what that is when you subtract 46 squared from both sides. All right. And then, so our height is actually equal to 30. I know this is pretty tricky because you wouldn't have thought that the height would have been outside the triangle, but it totally is possible. So our height then we can have as 30. All right, so now that we have our height, we can go ahead and plug into the formula, substitute into the formula. Area equals a half base times height. So a half, and our base, we may recall, is 19 inches. So a half times 19 times the height that we just found, which is 30 inches, will give us the area of our triangle. So our area is 285 inches squared. And that's it.